So we can start. Right. So good afternoon, students. So whether my screen is visible, I'm audible to everyone. Students.
Yes, sir, audible.
Yes. Correct. So welcome to the module 23, the IC engine subjects. Now in this session we are going to see about the combustion in CI engines. Right. So for the last class we've seen what is the injection pump and what are the injectors, right? What are the nozzles types are there, right? So for the injection pump, we've seen two types of pumps, right? One is the jerk type pump and one more is the distributor pump. Then the injectors, right? So the fuel atomizer or injector, right? So the types of the nozzles, right? So single hole nozzle, multi hole nozzle, pintle nozzle and pintex nozzle, right? So that we discussed in last class, right? So in this class we are going to see about the combustion in CI engines, right? So for the combustion of the CI engines, right? So the CI engines only sucks the air during the suction stroke, and the fuel is injected at the end of the compression stroke. At the end of the compression stroke, but in the SI engines, it's nearly a chemically correct mixture. That is, stoichiometric mixture of the fuel and air will be used in the SI engine. But in CI engine, only the air is sucked. Only the air is during the suction stroke, and the air is compressed, and the fuel is injected at the end of the compression stroke. Right. So while the CI engines right. So while the CA engines is 40 to 75 percentage, 40 to 75 percentage of the excess air is required, right? The excess air is required for the better combustion of the fuel, right? Better combustion of the combustible mixture, right? That we have to note, right? So the CI engine, only the air is sucked during the suction stroke, and at the end of the compression stroke, we can supply the fuel. We can inject the fuel through the injector, right? So while comparatively in SI engine, so here in the CI engine, we required 40 to 75% of excess air, right? 45 to 70% of excess air is required for the better combustion, right? So in C engine, the combustion starts. The combustion starts at uh, as one point, right? At one point, simultaneously, that is the multi-point combustion takes place. So simultaneously, at the combustion will be takes place in multi-cylinder engines, right? Then, so during the compression stroke, only the air is compressed to its a high compression ratio, that is 16 to 22, 16 to 22, right? So most of the CI engines we have get from the compression ratio between 12 is to 1 to 22 is to 1, right? 12 is to 1 to 22 is to 1, right? So here the compression ratio will be 16, right? So 16 to 22. So the temperature inside the cylinder, the temperature inside the cylinder, right? How we can generate the temperature, right? Means by compressing the air. By compressing the air, we have to generate the temperature, right? The temperature is around 440 to 550, right? So it is beyond the self ignition temperature of the diesel. It is beyond the self ignition temperature of the diesel. So the diesel will gets flame, right? The diesel will gets the flame, right? So at the end of the compression stroke, the high pressure fuel will be injected through the injector, right? So its pressure will be around 100 to 200 bar. 100 to 200 bar, the pressure will be, uh, sorry, the high pressure liquid, the high pressure fuel will be injected through the injector, right? So it's around 100 to 200 bar pressure, right? So then the atomized fuel vaporizes. And mixed with the air, and the combustion will be taking place, and the combustion will be taking place, right? So what are the points we have to remember means, so for the combustion of the CI engines, the combustion of the CI engines, only the suction of the air, right? So only the air is sucked in the suction stroke and it will compress. While compressing, the temperature will be increases. The temperature is used, the temperature is utilized to burn the fuel in the form of the vaporized fuel, right? The vaporized fuel will be mixed with the compressed air, right? So the while the compressing the air, the temperature will be develops around 500 degrees Celsius. It's around 500 degrees Celsius. It's beyond the self ignition temperature of the diesel fuel, that you have to remember, right? Then the stages of the combustion and the stages of the combustion, right? So for the SI engines, we seen the three stages, right? But in the CI engines, here we have four stages, right? So one is the ignition delay period. The first stage is the ignition delay period, right? Then the second stage is the period of uncontrolled combustion, and third one is the controlled combustion, right? So here these two, right? Just wait. Right. So uncontrolled combustion and period of the controlled combustion, right? So these two are the same, right? The ignition delay and the afterburning, right? So just then we can see one by one, right? So what is the ignition delay period, right? So before seeing this one, just we can give some introduction about the stages of the combustion, stages of the combustion in CI engines, right? So in the case of the compression ignition engine, CI engines, the air is alone is compressed and the rise of the pressure and the temperature during the end of the compression stroke, right? So by using this higher compression ratio, the temperature of the air is attained, the temperature of air is attained above the self ignition temperature, above the self ignition temperature of the diesel, right? The diesel fuel, right? That is around 500 degree Celsius, that you have to remember, right? So it is one of the objective type question, right? So what is the self ignition temperature of the diesel engine? It's above it's a 500 degrees Celsius, right? It's around 500 degrees Celsius is the self ignition temperature of the diesel fuel, right? Then the fuel is injected by the fuel pump into the combustion chamber at high pressure, right? So its pressure will be around 100 to 200 bar pressure, right? Then so you already know what is this diagram, right? This diagram will indicates the piston movement, right? The piston movement, that is uh, so here the piston will be moves from here to here, right? So for the compression stroke, right? So from the TDC and here the BDC will be there, right? So that will be indicated as the crank angle, that will be indicated as a crank angle, and the pressure, right? So the combustion stages will be indicated by using this graph between the pressure and the crank rotation, right? The crank rotation of the angle, right? Right. So the first stage is the ignition delay period, right? So I already told that what is the ignition delay, right? It is the time period. It's a time period between the start of the injection and the start of the ignition, right? Start of injection of fuel and start of ignition of the fuel, right? So that time period is called the ignition delay period, right? So the fuel leaves the nozzle initially in the form of the jet, right? Initially in the form of jet, and later on it will be disintegrates. It will be disintegrates into a core of fuel surrounded by the spray envelope, right? It is surrounded by the spray envelope of the air, right? And the fuel particles, due to the atomization and vaporization, it will be mixed with the air, right? That you have to remember, right? So the fuels will leave from the nozzle, right? It's initially in the form of the jet, and later on it will be disintegrates into the core fuel, which is presented surrounding the air, right? So it will be mixed together, right? It will be mixed together, right? So by the atomization, vaporization, right? So due to this, the proper mixture will be occurring, right? So due to the vaporization process of the fuel, it will receive the latent heat. It will receive the latent heat from the surrounding of the air, from the surrounding of the air, and due to this, right? So the slight drop in pressure in the cylinders, right? Slight drop in pressure in the cylinders, right? That will be indicated in this graph as AB, right? You can see as AB, right? So what will happen? First stage, right? First you may see this one during the compression stroke, right? During the compression stroke, what will happen? The pressure will be increases, right? The pressure will be increases. At the time, the temperature also increases, right? So here the A point, here the A point will be the fuel injection starts point. Fuel injection starts point, right? So while the fuel will be injected, so what will happen? The vaporization process will be taking place, right? The vaporization process will be taking place. So the fuel will absorb the heat, the latent heat from the compressed air, right? The compressed air, the latent heat will be absorbed. So on the time, the pressure will be slightly reduces. On the time, the pressure will be slightly reduces, right? So for that only we have drawn this graph. See, here the A point is there, but B point is here, right? So here we have a slight pressure drop. Here we have some slight pressure drop, right? So due to the vaporization process, the pressure drop will be there, right? So as soon as the vaporization is over, right? Once the vaporization is over, the free flame, that the pre-flame reaction of the air and the fuel mixtures, it starts, right? The free flame reaction will be starts in the mixture, right? Then so during such chemical reactions, the energy is released, right? The energy is released at a so slow rate, and the pressure starts to build up, right? The pressure starts to build up, right? So that it will be indicated in this graph. That will be indicated in this graph. You can see. So from the A, from the point A to B, right? So what will happen? The vaporization, due to vaporization process, the pressure will be slightly drops, right? So once the vaporization process will be gets over, right? So what will happen? The pre-flame will be occurs. The pre-flame reaction will be occurs. That is the chemical reactions, right? So that chemical reactions, the energy will be released, right? Due to the chemical reaction, the energy will be released at the slower rate. It will generate, right? It will generate, or it will build up the pressure, right? It will build up the pressure, right? So you can see the pressure will be gradually increases. The pressure will be gradually increases, right? So from the B to C, from B to C, so you can note that one, right? So therefore the free flame reaction first starts with a slow manner, and then it will be accelerates, until until the fuel ignitions takes place, right? So it will be represented the point C, right? It will be represented as the point C in this graph, right? So generally the ignition delay period will be in the form of two. One is the physical delay and one more is the chemical delay, right? So for the physical delay, it represents the time interval from the time of injection of the fuel, and the fuel auto ignites, sorry, what do you say, the physical delay is the time interval from the time of injection of the fuel to it attains, right? It attains the self ignition temperature. It will attains the self ignition temperature during which the fuel is atomized, vaporized and mixed with air, right? That is called the physical delay, right? So you note that one. Generally, what is the ignition delay, right? So the ignition delay will be the start of the injection and the start of the ignition, right? So that time period is called the ignition delay, right? The ignition delay will be categorized in the two forms. So one is the physical delay and one more is the chemical delay, right? So for the physical delay, right, it represents the time interval of the fuel will be injected from the injector, right, and the fuel will be attains the fuel gets attains its self ignition temperature due to the surrounding of the air, due to the latent heat which is presented in the surrounding of the air, right. So that time delay is called physical delay. That time delay is called physical delay. And the chemical delay, one more delay is the chemical delay, right. So after the physical delay gets over, right, so it will attains the self ignition temperature, right. So after that, the self ignition, due to the self ignition temperature, what will happen, the fuel gets ignited, the auto ignition, right, the auto ignition will be taking place. So the flame will be appears, right, the flame will be appears. That delay is called the chemical delay. That delay is called chemical delay, right. So you note that one, these two, these three terms are a 2 mark question, right. So generally, what is the ignition delay period? Ignition delay period is the time of the start of the injection from the nozzle, and start of the ignition from the mixture, right. So here the ignition delay will be in the two category. One is the physical delay and one more is the chemical delay. Physical delay means once the fuel will be injected from the injector, and that fuel, right, that fuel will takes the heat, right. So it will reaches the self ignition temperature. So it may take some time, that time delay is called the physical delay, right. So once it will take the self ignition temperature, right, once it receives the self ignition temperature, then the fuel will get the auto ignites, and the flame will be occurs, right. So that time delay is called chemical delay, right. So you note these two, right, so the what is the ignition delay period, and you may note these 3 points. So A, B, C in this graph. You can see these 3 points, these 3 points, right. So இப்ப இது புரிஞ்சப்ப இது
Yes, sir.
okay, right. So the second one is the period of uncontrolled combustion, right. So once the delay period is over, right, so the first stage will be completed, right. So after that, the delay period is over, the mixture of fuel and the air will auto ignite, since it's above its uh, self ignition temperature, right. So the ignition will be taking place, right. So the flame appears at one or more location where the concentration of the fuel and air mixture is optimum, right. So that you may note. So the flame will be appears one or more locations where the concentration of the fuel air mixture is optimum, right. So where the fuel mixture will be optimum, there the fuel flame appears will be there, right. So this is due to the fact of the mixture present in the combustion chamber, at the time of the ignition. The mixture, that is the air and fuel mixture, will be present in the combustion chamber, right. So it is extremely heterogeneous mixture, right. It is a heterogeneous mixture, right. So but in the SI engines we are using the homogeneous mixture, right. So for the SI engine we are using the homogeneous mixture, but in here we can get the heterogeneous mixture, right. So once the flame will be appears in the mixture, then the other regions will be burned by the propagating of the flame, right. It will be burned by the propagating of the flame, or it will auto ignite because of the heat transfer from the mixed burned mixture and the high temperature will be exist in the combustion chamber, right? So due to these two factors, the ignition, the flame will be propagates, right? So this type of the flame propagation is called the uncontrolled combustion, right? It will be called as the uncontrolled combustion, right? So at the time, the rate of the pressure rise depends on the fuel will be injected and the accumulated condition, right? The fuel will be injected and the accumulated, right? So which is directly proportional to the time of the injection and at the particular speed of the engine, right? So the higher would be the rate of the pressure rises, right? So the due to this pressure rises this period, right? So it is very difficult to control the amount of fuel burning, right? So it is very critical one, right? So that will be represented in the graph as a C and D point, right? So you may understand this one. Anyone? Uncontrolled combustion. இப்ப அது புரிஞ்சுச்சா? அது இல்லைன்னா சொல்லுங்க, மறுபடியும் சொல்றேன் அது.
Yes, sir.
So what will happen means in the second stage, right? So period of the uncontrolled combustion, right? So once the first stage is completed, right? Right? In the first stage, we can get the point A, B, and C, right? So the delay period will be completed at the point C, right? So once the delay period, either it's a physical delay or a chemical delay, the ignition delay period gets over. So what will happen? The flame will be appears, right? So in the chemical delay itself, the flame will be appears, right? So the flame appears in one place or in more places, right? Depending upon the concentrations, right? Depending upon the concentration of the fuel, right? So fuel in the mixture of air and the fuel in the combustion chamber, right? In the combustion chamber, so we have the fuel and air mixture, right? So here, for example, here the flame will be appears. So here the flame will be appears. Here the flame will be appears, right? So due to the more flame appearance in the combustion chamber, so what will happen? So the surrounding fluid will get the heat from the flame. So here a flame will be propagated. So here the flame will be propagated. Here the flame will be propagated, and here the multiple flame will be propagated. So the controlled combustion will not be there, right? So the controlled combustion will not be there. So the pressure will be increases. So the pressure will be abnormally, it will be increases from point C to from point D, right? So this time period, this stage is called the uncontrolled combustion, right? So this period is called the uncontrolled combustion, right? That will be represented in the C and D by this graph, right? So then the third one, again see from D to E, again the pressure will be increases, but so here it will be a controlled combustion. Here it will be a controlled combustion, right? So once the fuel will be accumulated, once the fuel will be accumulated during the delay period is burned in the period of the uncontrolled combustion, the temperature and the pressure inside the cylinder, right? Inside the cylinder will gets high, right? Will gets high. So the further quantity of the fuel will be injected will burn as soon as it will leaves from the nozzle provided by the sufficient oxygen which is present in the cylinder, right? Is it clear or not? So therefore the rate of pressure rise will be controlled, right? So the rate of pressure rise will be controlled by controlling of the fuel rate, by controlling of the rate of fuel which is injected from the nozzle, right? Which is injected from the nozzle. So that period is called the controlled combustion period. That period is called controlled combustion period. So it will be represented as D and E, D and E, right? So it's very simple one, right? It's a very simple one. So once the fuel, right? So for example, you can see it is the combustion chamber, right? It is the combustion chamber. In this combustion chamber, we have uh, fuel particles as well as the air particles, right? As well as the air particles, right? So for the second stage, what will happen once the ignition delay period will be gets over? Ignition delay period will gets over. At the end of the ignition delay period, what will happen? The flame will be appears. The flame will be the sorry. Right. So in this combustion chamber, here we have a mixture of here you can see, right? So here you have a mixture of the air and fuel, right? Air and fuel after the ignition delay period. So we have one or more flame, right? So the yellow will be indicates as a flame, right? So the pre-flame, one or more pre-flame will be appears, right? So due to this pre-flame, so the surrounding fuels which is presented in the combustion chamber will ignites, right? So here some fuel will be ignites, here some fuel will be ignites, here from fuel will be ignite, right? So due to this, what will happen means the uncontrolled combustion will be taking place, right? Due to this, the uncontrolled combustion will be taking place. So the pressure and the temperature will be drastically increases in the period of the uncontrolled combustion. So the pressure will be like this, C2D, right? So here the pressure will be increases, right? So once the uncontrolled combustion, right, at a particular limit period, so what will happen? So all the fuels will be gets burned, right? All the fuels will get burned condition, right? On the time, what will happen? So here the temperature and the pressure will be high. So on the time, the fuel will be injected from the nozzle. What will happen? So while it is coming out from the nozzle, it will be burns, right? So the fuel will be comes out from the nozzle, it will be burns. So here the burning will be somewhat uniform manner, right? So there the burning will be somewhat the uniform manner. So it is called as the controlled combustion. So it is called as controlled combustion. So on the time, what will happen? The pressure and the temperature will be slightly increases, right? So the pressure and temperature will be slightly increases. That point will be indicated as D and E in this graph, right? Then obviously, what about the stage one? Fourth stage is after burning, right? So for the theoretical one, so once the combustion will be taking place, after that the expansion stroke will be there, right? After that the expansion stroke will be there. But in actual, what will happen means, so during the expansion stroke also, we can get some fuel particles will be burning, right? So that will be called as the fired cycle, right? So that is called as the fired cycle. So during the expansion stroke, you may see, so here it is the expansion stroke, right? So during the expansion stroke also, the firing will be taking place, right? That firing, that burning is called the after burning, right? The burning is called the after burning stage, right? So after the E and the F point, after the E and F point, so we can get the after burning condition, after burning stage, right? So here we have a four stages, right? So here we have a four stages in the CI engines, right? uh, so anyone answer me, what is metering? Sorry, what is the term motoring? Motoring. Motoring. What is motoring? Anyone? Anyone? Mukesh? Mukesh D, are you there? Mukesh D. Right. Mukesh, what is motoring? What is motoring curve? You can see the diagram and answer. You can see the diagram itself. What is motoring? Small curves are not like that. Survey Saranjay.
Sir,
What is motoring curve?
தெரியல sir.
Right. So in SI engine also I clearly explained that one. Right. What is motoring curve? Right. So with firing and without firing. Right. So if you get with firing, right. So some cycles, right. So some cycles the crank rotation will be there without firing or without starting off an engine, right. So on the time due to the piston movement without firing we can get some pressure increases, right. So without firing some pressure will be increases. That curve is called the motoring curve. It's an important 2 mark question, right. You may remember that one, right. So if we get firing, so on the time what will happen, the pressure will be increased, like this, right. But in some cycles, some conditions, the engine will not start, right, will without starting, without firing, right, without the fuel injection. So what will happen, simply the crank will be rotates, the piston will be rotates from BDC to TDC and TDC to BDC. There is no fire, there is no ignition will be there, right. So that type of curve is called the motoring curve, right. So for that only, here you can see here the compression stroke and the expansion stroke, right. So whatever may be, the piston will be moves from BDC to TDC and TDC to BDC. So the stroke will be happens, but without firing, without firing. So what will happen during the compression stroke, due to the compression of the air, it pressure will be slightly increases and the temperature will be increases, right. So after the expansion, so suddenly the pressure will be drops and the temperature also drops, right. So if we get fires, then only we can get the abnormally, and the curve will be like this, right. So we can note what is the motoring curve, right. Is it clear? It's an important 2 mark question. Is it clear?
Yes, sir.
Right. Then we have several factors. Right, which is affecting the engine's performance, right, which is affecting the engine performance, right. So that we can see, right. So the first one is the compression ratio, right. So increased compression ratio increases the density, pressure and the temperature of the charges. Is it right or not, right? So the compression ratio will be increases, so what will happen, the amount of air will be sucks, it increases, right. So the density of the air, the density of the charge will be increases, pressure, temperature, right, these terms are increases. So the increased pressure and the temperature reduces the ignition delay period, right. So that's the first one, right. So in the term of the delay period, right. So what are the factors, what are the effect of the engine variables will be there, right? So these are the engine variables, right. We have 10 engine variables, right. So the first one is the compression ratio, right. So if the compression ratio increases the density, pressure, temperature of the charges, then the increased temperature and the pressure will reduces the delay time period. It will reduces the ignition, sorry, delay period, right. So then the inlet pressure, it's a supercharging, right, inlet pressure, right. So increased inlet pressure increases the pressure, right? So increase the inlet pressure increases the pressure in the compression stroke, and it reduces the ignition delay, right? The ignition delay period will be gets increases, then the ignition delay period will be gets reduction. Temperature, higher intake temperature will results the high temperature at the time of the fuel injection, so it will also reduces the ignition period, right? It will also reduces the ignition period, right? So the first three terms you can remember, right? So the compression ratio decreases the ignition delay period. If the compression ratio increases, the delay period will be get reduces, and the inlet temperature and the intake temperature and the inlet pressure will increases, so these also reduces the ignition delay period, right? Ignition delay period. And for the engine speed, right? So increased speed will increases the delay period, right? So increased speed of an engine, increased speed of an engine will increases the delay period in the terms of the crank rotation, the degree of the crank rotation, right? So then the water temperature, right? That is the radiated, right? That is the heat removed jacket water temperature, right? So the increased water temperature increases the temperature of the air inside the cylinder, hence it will reduces the ignition delay period, right? Then the load, say increase the load on the engine will reduces the ignition delay period, right? So the most of the terms, most of the engine variables will delay will reduces the delay period, right? So these are the engine variables, right? These are the engine variables which will affect the delay period, right? Then the fuels, right? If the fuel will get the higher ignition temperature, so that also reduces the ignition delay period. Then the injection pressure, right? If the pressure will be gives, so the more pressure will gives the better atomization of the fuel, so it is also reducing the tendency of the delay period, right? So these 10 engine variables will reduces the delay period of a ignition delay, right? So now we can stop this class up, right? Then the other one, the knocking stages, that will be discussed in next class, right? So knocking, what is abnormal combustion, then the comparisons effects, that will be discussed in next class, right? So in this class, do you have any doubt in this class?